YouTube. So whether you are watching on YouTube or on Zoom, we are so excited that you have come to join us today at the Field Museum in a capacity. I am at home, but we are going to be broadcasting from the Field Museum with my collaborator and oops, let me mute that. There we go. Okay, now we are on YouTube and on Zoom. We are everywhere all at the same time. Hello, everybody. On this discovery adventure, we are going to be taking a look at fossils in the museum, what we can learn from them, how they are excavated. Because this is a live program, we are very excited to be able to interact with you. So on Zoom, you're going to be able to access the chat or the Q&A. Feel free to send us questions throughout, and we'll try to answer as many as we can. And without further ado, I'm going to hand it over to our host in the building, Jeff Schroeder.
Thanks, Anna. Hi, everyone. I'm here at the Field Museum, so very excited to be able to do that. And we're going to talk fossils, like Anna said. So I'm going to be showing you some fossils, some actual fossils I have here, doing some activities. We like to be really interactive, so please do ask the questions and definitely add comments or thoughts in chat if you'd like to. But we're starting out right here outside the Evolving Planet exhibit, where most of the fossils are. So we're at the Fossil Prep Lab right now. And you can kind of see behind me this huge kind of thing laying there. And it's kind of hard with the reflection, but there's a big sort of hose or vent over it. And this is actually a fossil that is being worked on right now at the Field Museum. So once we can get everyone back and going, they'll be busy on this again. You can see 2,849 hours already of prep work on this. So it takes a long time sometimes to prepare a fossil. I'm going to go over really briefly how we find the fossils, and then as we take a little break and Anna has trivia for you, we're going to go into the exhibit. But you can see this is inside this weird kind of plaster looking thing. And anyone out there, if you have ever had like a broken arm or leg and had to put that in a cast, go ahead and raise your hand or chat to us, because this is kind of like that. Think about that. What does that cast do? Protects your arm, protects your leg, lets the bone stay stable. For a living thing, it would heal. For a fossil, it's not alive anymore. It would just protect it so they can work on it later. So paleontologists decide what they want to look for, what type of fossil. Then they might look at a map. Instead of topographical, it would actually show the ages of the different types of rock of the area they're looking at, say maybe Utah or Wyoming. They would use that map to find the right age for the fossil they're looking for, travel out there, and then that expertise comes into play. They look and they scan, they know the area, they refer back to the map, they use past experiences from paleontologists, and they hunt for fossils. And then, hopefully, they discover some.
Jeff, I have a quick question from Lena. What is that big fossil that we see in the window? Can you tell what that is?
Absolutely. So this is kind of a fossil of a lot of different things. This is from Fossil Lake, and it is, I don't know if you can see, probably not real well over there, but there's a picture of a paddlefish, and the paddlefish and other fish are contained in this. So they took a big hunk out, and there's a bunch of fish in there, ancient fish, and they're going to slowly but surely kind of excavate, try to take out the bones of those, the fossilized bones, and then study those. But it's a big work in progress. As you can see, it's very large. Its surface area is bigger than me.
That's really cool. So it's a whole chunk of different things that used to live in the water in that rock. And I know there's still paddlefish today, like at the Shedd Aquarium, I've seen them there. So that's very fun.
Absolutely. So right, like studying this fossil could tell us about paddlefish back then and paddlefish today and like how closely related they are. So lots of cool stuff to study with fossils. Yeah, so once our paleontologists have found it, oftentimes they will put the fossil into a big field jacket like this. That's like the cast. And they'll put some wet paper towels so things don't get too sticky. They'll put plaster over it, kind of cut it, get it out, flip it over, and do the same thing. So it's all encased, bring it back to the museum, and then start some prep work on it and study it when they are ready to get the chance. All right. Any other questions, Anna?
There are a lot of questions. Some of them we might get to later, but they are a lot of general fossil questions. One, I think about this specimen. Do we know how much it weighs? Which I don't know. Looks heavy.
Yeah, it's got to be pretty heavy. So one thing about fossilized bones, they're not truly bones anymore. the fossils have taken in minerals, and it's probably hard to see here. Yeah, if you can, let's see. Pretty difficult, but maybe if you look carefully there, you'll see that there's little darker areas that are a little darker than the rest. Those are the fossils, and they've mineralized. They've taken in different minerals, oftentimes iron or other heavy minerals, and those will make the fossils heavier than most of these things would have been in life. So yes, this probably is quite heavy. All right, so are you all ready to go into the exhibit?
I think we are ready to go into the exhibit. And while you're going into the exhibit, Jeff, I'll pull up that trivia question and I'll try to get through some of these other questions that people have asked as well. So let me go ahead and share my screen and launch a poll. Okay, so the question that we have for you all is what, oops, I lost where my screen is. Okay, there it is. What is the oldest living thing to ever become fossilized? I'm gonna make a poll pop up so you can answer that question. And this kind of goes with some of the questions that have been coming through in the chat. People are wondering what is the oldest fossil. So you should see a poll now. What is the oldest living thing to ever become fossilized? The options are trilobites, early plants, bacteria, or Barney. If you're familiar with the Barney character, what is the oldest living thing to become fossilized? And we see that we've gotten questions like, what is the first fossil that had been discovered? And that's, I guess, a different type of question, right? And people have been around for a very long time. And so early people have been finding fossils that we maybe don't have an exact record of because we didn't have the same recorded history that we do today. We can talk a little bit about the history of our known paleontology later. But even the ideas of dragon myths, right? Those might be started from fossils of giant creatures that people found. Oh, another question is, how did people decide to call them fossils? That is a really good question, and we can ask Jeff about that later. And somebody else was asking, can you tell if it's really old, or how can you tell how old fossils are? And we will touch on that as well. As Jeff was talking about a little bit, you can see on maps or in the earth the different depths of the rock. The deeper you are, the older the rocks are, and there's different ways we can analyze it too. They can use radiocarbon dating or other types of isotopic analyses where they look at the chemicals and they're able to see what has naturally degraded over time, and they can figure out approximately how old it is. So those are some of the tricks to see what is really old. And it looks like so far in the poll, most of us have voted, and we are getting a lot of interesting responses. The most popular choice has been bacteria so far. And in second place is trilobites, and then plants, and then Barney. Barney has only gotten 9% of the vote. And I think that's pretty reasonable, but we have 42% right now thinking it's bacteria. And I see that Jeff is back. Hello, Jeff.
Hey, Anna. Yes, I'm back.
Reveal for us the oldest fossils.
Yeah, all right. So I'm back here with some different creatures, and we're gonna scroll down. We're gonna move down. We've got an Edaphosaurus behind me. That's good. All right, let me get back into the light here. And it looks like bacteria was the winner in our poll. Excellent. And we got some trilobites and early plants. So indeed, bacteria is the oldest living thing to ever be found fossilized. And lo and behold, I actually have some here. So let me grab this. And I'm also going to talk a little bit about what a fossil actually is. So let me grab the bacteria. Okay, so I have two items here, and we're going to see, let's see, there we go. Excellent. So we can get those in the camera. Now, one of these is a fossil, and one of them is not. Now, this is something that used to be bacteria. And you can see these layers. Bacteria are so small, right? You think you'd see an individual bacteria or bacterium if it fossilized? Probably not. But we can see what's left behind as they form colonies of millions or billions of these little things and form kind of mats. So this is evidence of bacteria that could have lived like up to maybe 2.5 to 3.5 billion years ago, maybe even more. But these things lived a long time ago, not millions, but billions of years. Now this is something cool. It is not a fossil, but this is banded iron. You can see the little lines or the bands on there, if I get it right. There we go. And that banded iron actually shows rust. Now, if you think about rust, how does rust happen? Anyone ever had a bike get a little rusty or something like that on them?
Yeah, I know if I have like metal that gets wet and then left outside, that usually is a big part of the problem if my bike gets rusty.
Yeah, right. So the water and then the oxygen, it's that oxidization. And so it's showing how much oxygen there is. So these two fossil, or the fossil is telling a story along with the other thing, the iron, and it's telling us that oxygen was increasing. What can we trace that to? The bacteria. And so it tells us a story, and we're going to tell more stories through fossils later. But first, I need to do our little fossil quiz. Let's talk about what is and isn't a fossil. And I'm sorry I'm moving around. I'm trying to get a little bit better light on me here. There we go. That's a little better. So I've got some items here. Now, when we talk about fossils, Anna, there's two main things that we want to remember that make something a fossil. And the first, if you remember, the iron itself wasn't a fossil. The bacteria was. Bacteria is a living thing, even though it's tiny. So a fossil has to have once been alive, or at least a trace or evidence of something that's actually alive. So you could have a footprint that's a fossil. It's not the real foot, but the dinosaur leaves it. That's a trace fossil. You can have an actual bone from a dinosaur that's fossilized. That's a fossil as well, because it used to be alive. Now, the other thing, though, is that living thing has to have turned into some type of mineral. So again, it's kind of become a rock. It's not a living thing anymore, but it is one that has turned into a rock. So we got to have was alive, turned into a mineral. All right, I've got some items, and I'm going to quiz everyone in the audience. So feel free to just chat us a Y or N for yes or no, depending on what you think. Fossil or not a fossil? Remember your 2 points. Was it alive? But also, has it turned into a mineral? All right.
All right, so taking a look at that, do you think it was something that was alive that is now turned into a mineral like a rock? It looks like we have some already saying yes and some saying no. Yeah. And if you hold that really still, Jeff, that helps us see it the best. And now we're getting a lot of yeses. It looks like the yeses are overwhelming the no's. Somebody says it looks like a bone. Lots and lots of yeses.
Nice. Good. So this is indeed a fossil. This is a fossilized trilobite. So we talked about trilobites. They're not the oldest things fossilized, but they are quite old. They're ancient little arthropods, basically related to horseshoe crabs. Hard to hold that real still, but there you go. That's a trilobite. So that is a fossil. It was alive and it's turned into a rock or mineral. So here's something else. I'm going to hold that still. Fossil or not?
Yes, you can type into the chat, yes or no, is this a fossil?
Now remember, your 2 points to a fossil. It used to be alive and it's turned into a rock or a mineral. Like we said, dinosaur.
We're getting a lot of yeses. We do have more no's than we did last time. We're getting some yes question mark.
Okay.
Somebody said yes, and I also think it's an animal.
Oh, I love that thought. It does. It looks a lot like an animal, doesn't it? Like a bone. So one thing I want everyone to pay attention to, and Anna, see what you think. Does this look like it's turned into a rock, or does it look like it's still bone?
That looks like pretty fresh bone to me. Like if I was going to eat chicken wings or something and see those bones in the inside, it would look kind of like this type of bone.
Yeah, and Leanne said that they think it's a beaver. Correct, this is a beaver. So the thing is, this is not a fossil yet. So this was alive. It meets the first criteria, but it has not turned into a rock yet. This is still actual bone. It's from a beaver. And like Anna said, I mean, I could be walking along a creek 2 days from now and find something just like this. coming from an animal. So it hasn't had a chance to fossilize or turn into a mineral yet. So it could become a fossil if it was stuck in the ground a long time, but it's not yet. All right, let's do one more quick, and then we're going to move on. I'm going to have 2 items here. I think.
Somebody did ask how we identify them from the bones, and as you might have, some people were guessing what type of animal that is. It is a lot of comparing the bones to animals that are alive today or to other fossils. So just examining the bones, that is how we figure out what they are.
Yeah. All right, so this time I'm going to throw 2 of them at you together, and I'm going to have you tell me which one you think is the fossil, and you can do it by color. So is it the orange one or the black one? We've got 2 things here. They both look, to me, like shells. Which one is the real fossil, orange or black? And you can even put O or B if you want.
Most people are saying the black one. Some people have noted that it looks like a seashell, but we do seem pretty unified on this one. I haven't seen anybody going for orange yet.
All right, yeah. So this is not a fossil because even though it came from a living thing, it's a shell, it's still a shell. You could find this on the beach tomorrow if you happen to have a beach nearby where shells are at. This one, though, is millions, if not a couple 100 million years old. This is an ancient brachiopod. It does look like a shell, right? Very similar, but this creature lived a long time ago, and this has turned into a solid mineral or rock. So that's the difference between a fossil and not. Nice job on those. All right, so I'm going to show you one more really cool thing here before we move on to our next spot. And we're going to talk next about the stories that fossils tell us. Now, here's a quick story. I'm going to get something from the bottom of the cart since we're in this area. And here we go. All right. So let's get this animal up here. Okay, so take a look at this. There's one more thing I want to kind of set out here is that you can also have something called a cast. And a cast is an exact copy made from a real fossil. So it's very accurate, it just isn't the fossil itself. This is a cast, so this is much lighter than the fossil would be, but everything, see all those little lines? Down to the slightest detail is taken out of a mold, basically, from the real fossil. So this is very, very accurate. So let everyone take a look at that. Now, this looks like, anyone have an idea of what this is? Feel free to chat it.
Somebody was thinking that it is a velociraptor.
Okay.
Rex.
Okay.
Somebody else also thought it might be a raptor or a T-Rex. A lot of carnivores, or a bear.
Okay.
Bear dog. Oh, here we go. Ernie says Dimetrodon.
Nice, Ernie. Yeah, Dimetrodon. So this is indeed from a Dimetrodon. Lots of great answers, though. And let's talk real quick about Dimetrodon. So that's that animal you see back here with the sail on its back. And the weird thing about Dimetrodon, this does look a lot like a dinosaur skull, and a lot of people were saying that. But some things we can learn when we look really carefully at fossils, at the details. Now, one thing paleontologists have learned is that dinosaurs, right behind their eye, they're diapsids. They have 2 holes back there. If you look at this animal, I see an eye. Anna, how many holes do you count behind the eye?
That is solidly 1. I can count to 1, and that's all I see right there.
Absolutely 1. That rules it out as a dinosaur. These things, like Dimetrodon, are actually called synapsids. They are not dinosaurs. They're more related to us. Now,
yeah, somebody also commented that it might be an ear.
An ear? So an ear opening could go back there? I love that thought. Great one. Yeah. Now I'm going to move to the next spot with a few more fossils of some actual dinosaurs. So let's see. Anna, you have, I believe, fun fact or slide for people to look at.
I do. So I'm going to go ahead and share my screen and go to our next picture. And so what's really cool about some of these pictures is we can see a lot of detail, and I'll try to use some of these details to touch on some questions that have been coming up in the Q&A. So somebody asked, how can we tell if a bone is a sea creature or a land creature? That's a great question, and we rely a lot on comparing them to animals today. So that picture you see on the screen, I hope to you that looks like a fish. I know for me that looks like a lot of fish I have seen before. And so when we see bones that look a lot like fish today, we're usually pretty confident it was a fish from the past. Or if we see things with arms and legs that look like creatures that walk on the land today, we think they maybe walked on the land in the past. But we're still learning new things all the time about fossils, like how Spinosaurus was an animal with arms and legs that maybe spent some time in the water. The more we learn about their tails, we can see some of those aquatic adaptations. And on this fish, one of the things that's really fun, you can see the tail of one kind of sticking out of the mouth of another one. So definitely a really cool way to see how animals interacted. And that was another question. Why do people study fossils? A big part of it is just to learn about life from the past. So it helps us understand what was alive, how they lived, how they died, how they interacted. It just helps us build up a better picture of life on Earth across time. And it looks like Jeff is in another exciting location. So I'm going to go ahead and stop my share for a second.
Yeah. So I am now in the Hall of the Dinosaurs. So behind me, you can actually see several fossils. The meat eater here, the theropod that looks like a T-Rex but is actually smaller, is Dysplatosaurus. We have Lambeosaurus, a duckbill type laying on the ground, and that is actually a cast of a Triceratops. So these two have real fossils, Triceratops does not. It can be hard to tell the difference, but even the Triceratops is based on actual fossils. So we have some dinosaurs behind me now. And I want to talk about a little bit about some of the stories that fossils tell. Just like Anna showed that fish eating another fish. That's telling us about how these animals interacted, like what kind of fish might eat another one. Now, I've got a couple more that show some cool things here. So I've got this guy right here. This is actually a model of a creature called a Tully Monster. Not a dinosaur by any stretch, but this creature is Illinois' state fossil. So those of you who are from Illinois, this is your proud state fossil here, the Tully Monster. But the reason it's important to have fossils is that they can tell us about what this animal is. So if you look at this creature, look at its shape and its form, any idea what in the world this thing is? What kind of animal? I see
Looks
question
like
marks.
an alien
It
for
does.
sure. But yeah, you can put in the chat anything you think is kind of like somebody put a squid.
Yeah.
People typing in Tully. Oh, frog and fish mixed. Somebody else for squid and frog. Fish.
Nice. Yeah. So this, our scientists were really puzzled by it too. Like, what in the world? A squid, a worm, some kind of fish? But by studying over 2,500 fossils of this creature found only in Illinois, they were able to learn the story that it's actually a type of fish. And this is real size. So this thing was not really that big. It was a little animal swimming around here. So fossils can tell us all sorts of really, really cool stories. Anna, do we have any questions coming in about dinosaurs or fossils here?
You have all sorts of questions. So one of them is, where do you guys mainly find them?
Oh, wow. Yeah. All over the place. So I know some of the best fossil hunting areas that you could say best, depending on what you're looking for. There's a lot found in China. There's a lot found in Argentina, in the Western United States, but fossils are found all over the place. I know some of the places Field Museum has looked include Africa, like in Zambia, and Antarctica. Our scientists actually go to Antarctica to look for fossils on exposed rock on like mountain faces. And of course, the United States in the West, like Utah and Montana and places like that. But fossils can be found everywhere, every continent on Earth, and dinosaurs, many of those places, although not in Illinois. It all depends on what age of rock you have up.
Yeah, that is very true. Another question I like is it possible to revive dinosaurs?
Is it possible to revive dinosaurs? So one of the things to remember is, let me flip around here and let's see if we can get a view at all. Sorry for the quick dizziness, everyone, but there we go. A little hard to see. We've got some things in the background here. There we go. It probably looks a little like a velociraptor. It's sort of loosely what they were based on called Deinonychus. But we have a lot of evidence for feathered dinosaurs. We also have a lot of evidence coming out that dinosaurs aren't extinct. That when the asteroid hit the Earth, dinosaurs actually survived. A few, not many. Please chat if you know what I'm talking about. What dinosaurs survived the mass extinction? They were small. They didn't need much food. They had feathers.
Yeah, it's coming in through the chat. We've got a few people saying birds, alligator, lizard, birds.
Yeah, lots of reptiles like lizards and alligators are related, but the true dinosaurs that survived are birds. Yeah, birds are today's dinosaurs. So you can actually go out and you can see dinosaurs outside. I could probably see one out the window if I look carefully here. So birds are today's dinosaurs. Now, the question about bringing back maybe a Mesozoic era dinosaur from 67 million years ago, right now we don't have that technology. It seems doubtful because you need really intact DNA, and DNA degrades pretty fast. In the future, technology, who knows? But right now it's not really much of a possibility. But the cool thing is you can go see dinosaurs outside right now in the form of birds. So Anna, I know we're getting a little short on time, and I want to make sure we hit the star of the show. So I'm gonna.
Yep. And somebody did ask, are we going to see Sue? So I think Jeff is going to help us get to that. I'll pull up another screen while we are on our way to Sue. This is another really cool sea creature. You all can look at it. What type of animal does this one remind you of? Does this look like anything anybody has ever seen before? It's a pretty funky fossil. Somebody says jellyfish, a hummingbird, a stingray. These are all awesome ideas. Stingray, a bee. It's a pretty funky looking fossil. So this one is actually a relative of the rays, like a stingray. And someone else, there's been some questions about how things fossilize. So it is when the hard parts of your body that last longer are able to be replaced with rocks. And sometimes it's harder for soft animals to fossilize like jellyfish or even stingrays that are mostly cartilage. But this is a pretty cool example of a stingray fossil. And it looks like Jeff has made it to Sue. So I'll go ahead and stop sharing my screen so we can look at the most famous fossil. Oh, and there's been some
What are we doing?
about can fossils break? And absolutely can and do.
Lost me here. I think my connection is a bit off.
Yeah, I think your connection's a little spotty, so I can spiel for a minute while the internet reconnects for Jeff. But there have been some questions about, do we put the fossils together or do they break? Fossils can be really fragile, so they can and do break, sometimes from nature and all the rocks that are crushing them over time or erosion, and sometimes that can happen from people dropping them. So a lot of paleontology is putting things back together, whether it's all the individual bones or sometimes broken bones. And Sue is a really cool example of a mounted skeleton where they put all the bones they could find on a really nice metal structure that holds all the bones in place. So there's a lot of art and science that comes together to make these displays. And Jeff is going to be able to talk to us about this really beautiful dinosaur.
Yeah. All right.
Oh, okay. Maybe Jeff is gone. That's okay. I'm still here. We'll get Jeff back on the internet in a second so that we can see Sue. There's been some other questions too. Jeff touched on this briefly. How did the dinosaurs die? What happened to them? So there was a very large asteroid impact in what is today the Yucatan Peninsula. So right in the kind of Gulf of Mexico area. And you can even see that under the water today, that big impression. And when meteorites are coming into Earth, they bring some different types of minerals that are not common on Earth. And so we can actually see a layer of this special type of mineral called iridium all across the earth. It got brought by this meteorite and got kicked up into the dust everywhere. So that's one of the clues we can see everywhere about that big impact. But that impact caused a lot of changes. There was a lot in the air, so that changed the way that the sun interacts with everything. So we did not have access to light, which would kill plants, and then there's less herbivores, and then the meat eaters don't have as much plant eaters to eat, and so there's a lot less dinosaurs. But some animals did survive. And somebody has commented they hope Jeff didn't get eaten by the dinosaurs. I hope not. You know, if you've ever seen Night at the Museum, there's always the possibility that our exhibits come to life when nobody's there. So without being open to the public, our dinosaurs are kind of going rogue and maybe going for Jeff, which is pretty wild. But hopefully Jeff can come back. And somebody also wanted clarity on the word revive. We brought that up with reviving dinosaurs. That would be bringing them back to life. So there are some scientists that are looking at different extinct animals, sometimes more recently extinct, like a mammoth or even the passenger pigeon. But as Jeff talked about, the dinosaurs have been gone for a really long time, so we don't have enough DNA to look at that realistically right now. There's also been questions about where to find different types of dinosaurs or other fossils, and it really depends on where you are. For example, the Tully Monster is only found in Illinois. There's a lot of other dinosaurs we could find out west in Montana or Colorado. In fact, the Tully Monster isn't a dinosaur. It's a really funky fish relative. And depending on where you are, your rocks are a different age. So we don't have rocks in Illinois that are the right age to be dinosaurs, but in other places you do. So you can look at really cool maps that show the ages of rocks all over the world and see what types of fossils might live where you are or might be found. They are all dead. They won't be alive. Let me see if there's any other questions I can hit on. Can it break the land to form new continents? Yeah, so the land does change in tectonic plates over time. And so that's what's kind of fun is we can figure out the way that the Earth's continents have moved, because sometimes we can find certain species that are in both Africa and South America. Now they're separated by a lot of ocean, but they used to be a connected landmass where animals were all living, which is pretty cool. In case you have to leave, I know some people might be in school, might have other lessons to get to. We do have a lot of programs about Sioux. So if you do want to see Sioux, if you have to go, check out on the website for the Field Museum. We have a Sioux virtual tour, and you're able to sign up for that and learn all about Sioux and see Sioux's exhibit. So definitely check into that. And somebody asked who found Sioux. Sue Hendrickson is a real person and fossil enthusiast, paleontologist, who found Sioux sticking out of the rock face, and then a whole team worked to get Sioux out of the rocks. And we've also put the link for the Sioux virtual tour in the chat. So if you're looking for the Sioux tour, definitely go ahead and try out that program. It's really fun. And we also do discovery adventures like this, where you can chat us your questions and we talk about things in the museum every week. So our next one is going to be about bats. So if you're really curious about these amazing flying mammals, definitely feel free to sign up for that or check out what other ones we have coming up in the future as well. And indeed, Sue might have eaten Jeff. That is a question that keeps coming up. I hope not. Sue being extinct, I didn't think needed to eat anymore. But those T-Rexes are pretty ferocious. They have the strongest bite force of any animal that we've ever known. And that could really do a lot of damage to Jeff. For any kids that are watching, in general, we think about, I think it's somewhere between like 80, 90 pounds a T-Rex could like eat in one bite. So if you have yourself or any younger siblings or pets that fit in that range, you know, something to watch out for with Sue. Oh, there's another question. Thank you for putting these back at the top of my radar. What is the smallest dinosaur? That is an amazingly good question. A lot of people forget that dinosaurs aren't all very big like Sue. There's plenty of small dinosaurs. I don't know what exactly the smallest one is, but some of the smaller ones include Compsognathus, which is like kind of cute little chicken-like carnivore. but there's a lot of really small dinosaurs and small animals that lived during the time of the dinosaurs. Mammals were alive during that time, but were usually pretty small, like today's rats. Somebody asked, can I be a fossil? Maybe, but it would take a really long time in the right conditions. You need to be in the exact right conditions that you will be slowly replaced with minerals over time. Usually being near the water is very helpful. So they think that Sue, for example, died near the water and was buried by sand. And somebody asked, what is the largest dinosaur? The largest dinosaur that we have found so far is Patagotitan majorum. And that is a big, long-necked dinosaur. The kind of shorter name for it is a titanosaur, but titanosaur is also a family of some other long-necked dinosaurs. And the biggest specimen is something we call Maximo, and Maximo can be found in the middle of the Field Museum. We have a cast of Maximo, so it's the real size and the real shape. And the bones are copies, so you can actually get up and touch them and take a close look at them, which is really cool. And somebody asked, how many dinos are there? So as far as species go, there are hundreds of different dinosaur species that we know of, and we're still finding new species all the time. And as far as individuals, just like today, there's flocks of hundreds of birds. There used to be herds of hundreds of dinosaurs. So there were definitely a lot of dinosaurs. And we'll never exactly know how many there were because only some of them are fossilized. Oh, and somebody asked, can some dinosaurs actually fly in the air? That's a really good question. There were prehistoric animals that flew, like pterodactyl and the pterosaurs. There's a number of things that flew. They're all in the pterosaur family. Pterodactyl is the most common name, but you may have heard of Quetzalcoatlus, which is really big, like 30-foot wingspan big, flapping around. So there were a lot of things that flew, but they're technically not dinosaurs. They're in their own category. They're related, similar to how crocodiles are related, but not dinosaurs. And one of the things we can look at is the structure of their legs and hips. The dinosaurs have legs that go right underneath them. This is my handy dandy, scientifically accurate Stegosaurus. You can see its legs go right underneath it. If you think about other reptiles that are not dinosaurs, like a chameleon or an alligator or a gecko, their arms and legs kind of go out to the side. So that's one of the things we can look for. Well, thank you all for coming on our tour today. I'm sorry that Jeff got eaten by Sue. Hopefully we're going to be able to bring Jeff back from extinction so that he can do some more fun programs for us in the future. This is unprecedented, but dinosaurs are pretty intense and ferocious. Thank you all for joining us on this fossil tour. Definitely, if you enjoyed it, try to come back for more. These do happen every week, and we told you about the Sue tour as well. But I hope you all had fun, stay safe, stay curious, and we hope